And now let's move to our next speaker. Peter on the chat line says, Deep Fake Spence. I like it. That's my new nickname. Here to speak about the rise of machines, artificial intelligence in security is a representative of one of our platinum sponsors, Checkmarx. Maty Siman is CTO and founder of Checkmarx, a technology expert possessing nearly 15 years experience in software development, IT security, and source code analysis. Prior to founding our platinum sponsor Checkmarx, Maty worked for 2 years at the Israeli Prime Minister's office as a senior IT security expert and project manager. Woo-hoo. He'd have some stories he probably can't tell, and spent 6 years with the Israeli Defense Forces, where he was elected to the Star Excellence Program. Maty regularly speaks at IT conferences and holds the highly regarded CISSP certification, which he earned in 2003. Ladies and gentlemen, a big virtual welcome to the one and only Maty Siman from Checkmarx. Maty, take it away.
Everyone, and thank you for joining me today. For those of you who attended last year's presentation, it was titled as Software is Everywhere. We have demonstrated how hackers can hack into autonomous cars, exfiltrate data with smart light bulbs, and we even showed how we can turn every Alexa device into an eavesdropping device. This year, I want to make an even bolder statement. I want to say that AI software is everywhere, artificial intelligence. There are dozens of small startups that try to disrupt their respective market using AI. With healthcare industry, you can see that there are companies that build chatbots, wearable devices, drug discovery. They all use AI to improve the healthcare industry. The same goes with the fintech industry and the e-commerce. But it is not limited only to the smaller players in the market, small startups. Even the largest companies in the world, like IBM, Google, Yahoo, Microsoft, and Facebook, they all use AI to improve their service they're providing. When we upload a picture, when we upload an image or a photo to Facebook, it uses AI for face tagging. Whenever we call for an Uber, the estimated time of arrival is based on AI. When we go to Amazon and we look into things that we want to purchase, the recommendation is also based on AI. But I think that one of the companies really topped them all, and I want to focus on Google. Google wants all the information in the world to be searchable. That's their business. One of the problems they're facing is the fact that there is a lot of data and information in the world that is not stored in the web. It is stored only in humans' minds. And this information is not searchable by Google. So the first step for them to be able to make that information searchable is by asking and interviewing people about their knowledge, talking with these people, and then storing that information in their servers. So the first step is to build a bot that is capable of having a human-like conversation over the phone with people. And by having that, people will share that information with Google. Just as an example, the other day I was looking for the opening hours in one of the stores under my apartment, and I couldn't find it because that store doesn't have a website. Google wants to build a bot that is capable of calling that store and asking them about their opening hours. So the first step is to build a bot that is capable of handling a human-like conversation over the phone. Let's see where they stand.
So how can I help you?
Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd.
Sure, give me 1 second. Sure, what time are you looking for around?
At 12 p.m.
We do not have a 12 p.m. available. The closest we have to that is a 1:15.
Do you have anything between 10 a.m. and 12 p.m.?
Depending on what service she would like. What service is she looking for?
Just a woman's haircut for now.
Okay, we have a 10 o'clock.
10 a.m. is fine.
Okay, what's her first name?
The first name is Lisa.
Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd.
Okay, great. Thanks.
Great. Have a great day. Bye.
Okay, so far we've seen how a computer can mimic a human's behavior. But now let's play a game. I want to show how a computer can play a game better than any human being. For that purpose, I've chosen to show you the Flappy Birds game. For those of you who are not familiar, in this game, the birds need to flap its wings in order to pass through the different tree branches without hitting any of these branches. And it really depends whether the bird is close enough or too far, too high, or too low, and so on and so forth. Now, in order to teach the computer how to win this game, there are two approaches. The classic approach would be for me as a human being to understand the winning strategy, and then to feed that strategy as an algorithm. In case you're very close, don't flap your wing. If you're high, don't flap it. But if you're really at the right height, then flap the wings. And the other approach would be to let the computer learn on its own how to play this game, just to play many, many games until it automatically learns the winning strategy. For this demonstration, we've chosen the genetic algorithm to win this game. With genetic algorithm, we're going to create a generation of 10 birds that just flap their wings completely randomly. Some of them, by pure luck, will play better than others. We take the birds that fly better than others, we breed them together, we create another generation of 10 birds as offsprings of these winning birds. We slightly mutate each of these birds just to give it a chance to play better than its parents, and we play another generation. And then we take the best birds, we breed them together, and another generation, and another generation, and another generation. Hopefully, at the end, we'll reach to a bird that plays this game very, very well, and we didn't have to teach it how to play. Just by the fact that it wins, it becomes a better bird. So the motivation is to teach the birds how to flap optimally in order to fly safely without prior knowledge of winning strategy using genetic algorithm. First, we create initial population randomly. And then as the game is being played, we employ natural evolution. We select the best samples, we cross over and mutate. Now, a key concept here is the target function. We want to maximize a value. If we compare two birds, we want to maximize something. That something in this case would be the distance traveled by each bird. So we want to improve or to maximize that value. We take two birds, and the one that traversed the most distance is the better bird for our needs. So let's see how it goes live. So we start with the first generation. Second generation. Fourth. Fifth. And we have reached by the 73rd generation a winning bird, which is practically invincible. You can see that the red arrow points to the distance traveled by that bird, 138 units, which is by far the best bird. And again, I didn't have to teach it anything. Even if the rules of the games would have been different, the trees are moving or some of them are narrow or so on and so forth, it doesn't really matter. The bird will learn how to win this game. But this is a security conference, so let's wear our black hat for a moment. Let's play the very same game, but instead of birds, we will have worms and viruses. Instead of tree branches, we will have antiviruses, detection mechanisms. And the target function that we want to maximize is to get the maximum number of antiviruses that our virus can go through without being detected. So we will start with the virus, and then we will mutate it and mutated it, so on and so forth, until we reach to a point where none of the available antiviruses is able to detect it. So we will start with the virus, or with the worm, that gets detected by 42 antiviruses. Okay, that's a start. We will create another generation where each of the worms is slightly mutated. And then we see that the yellow and blue ones are detected by the least number of antiviruses, only 18 and 19. So we take these two worms together, we breed them together, we create another generation, and we slightly mutate each of these worms again. We rescan all these worms. We see that the middle two ones are the best ones for our purposes. So we merge them together, and now we get to a worm which gets completely undetected by any of the antiviruses. So just think about that. Just by creating another generation, we reach to the point where none of the antiviruses is able to find our new virus, although it really maintains the very same malicious activities that it had at the beginning. So let's see how it goes. For the purpose of this demonstration, I chose the I love you virus for several reasons. First of all, it's a very old virus, I think 20 years old, something like that. So most of the antiviruses in the world are able to detect it. Also, since it is a very famous virus, most of you probably already know of it. And third is that it was developed in VBScript, so it's very easy for us to mutate it and while keeping its very same functionality. Okay. So when I run the original I love you on my computer, my antivirus blocks it. That's great. When I scan it with VirusTotal, it's a web service that runs, I think, 57 different antiviruses against your virus. 55. So I see that 42 of the antiviruses are able to detect it. You see it's all red. Okay. Now we run the genetic algorithm. On the left-hand side is the execution itself. On the right-hand side, we see the different mutations. I have accelerated the time a bit just to fit into the time frame of this session. And now we got to what the algorithm believes is the best version of the virus. Okay, same malicious payload, but it completely mutated. Now when I scan it with my computer, with VirusTotal, we see that it gets all clean. And then when I run it on my computer, we see that it does deliver its malicious payload. So no matter how many signatures you add into your antivirus, still you get to the point where the virus is able to mutate itself, so it gets completely undetected by the antiviruses. So it might take another generation, another 1,000 generations. It doesn't really matter. At the end of the day, we will get to the point where the virus gets completely undetected. The next topic I want to talk about is whaling and phishing. I guess most of you are familiar with phishing, and a question that is raised very often is, well, why there are so many spelling mistakes in these phishing mails? Why can't they just run a spell checker before sending these mails? So Microsoft looked into that, and they have released a very interesting paper finally titled as "Why Do Nigerian Scammers Say They're from Nigeria?" And the conclusion is that they want to improve their success rate. They want to address the less knowledgeable and less educated population. So by having many spelling mistakes, the more knowledgeable people will not click the links, and the ones that are left at that funnel still clicking on that link are the ones that might be easier to convince to transfer you some money. So they want to improve the conversion rate. So and by having all these mistakes, they're really able to find the people that are easier to convince. At the other side of the spectrum, there is the whaling attack. Whaling is very similar to phishing, but phishing goes with spray and pray, where whaling, you want to have one specific person in an organization that you want to attack because that specific person has the ability to do something that is very significant to you or has enough data for you to get. So about whaling, having a properly whaling attack requires 3 steps. First of all, you need to identify the targets. Then you need to collect enough intelligence around that target to build a very convincing mail, convincing scenario. And then you need to craft that mail. We will show how each of these 3 steps can be automated and improved and scaled using AI. So starting with identifying targets, so far it's been a very manual process. You go to LinkedIn, you go to different social networks, and you try to understand who's the most relevant person to attack within an organization. We have built a tool, a Chrome extension that connects to LinkedIn. You mark 3 people that match the profile that interests you. In this case, these are software engineers in an insurance company. So you mark 3 people, only 3 people, and then it automatically shows you what these people have in common and to what extent it is in common between these people. And then the next step, once it computes all this value, it is able to create a Google search. In this case, it found all the people within in Google that are developers in an insurance company within the US. I think it found more than 500, or Europe. I think it found more than 500 such people in this specific search. So that's the first step of automation. The second step of automation would be to gather sensitive data around these people through social network harvesting. For the third step, to build a very convincing mail. So just taking Kendrick McCarter as an example, we have found all that information about this person in the social network. We saw that in LinkedIn, he was endorsed by Gopi Kodoravali. We see that he marked in LinkedIn data analysis as one of his skills. And we saw on Instagram that he was on vacation at the Venetian Las Vegas. In addition to that, you see at the success rate, based on previous whaling attacks that were performed, what's the success rate of an attack if we use that piece of information? We see, for example, that if we mention the data analysis as a skill, it has only 5% success rate. But if we mention that he stayed at the Venetian Las Vegas, it raises our success rate to 24% because it's probably more tailor-made to that specific person. And now we get to the interesting part. We can mark 2 of these attributes, for example, endorser and skills, and generate a mail out of these, automatically generate mails out of these 2 pieces of information. And it creates the following mail. Dear Kendrick, I've received your information from Gopi Kodoravali, whom I used to work for at Visio. I understand from him that you're in the data analytics field. Please find my CV. I'd be happy to get your thoughts. Now, this mail has a lot of accurate information. I've mentioned Gopi Kodoravali. I mentioned Visio, information that I took from LinkedIn, and the data analytics, which was marked as a skill. There are high chances that the recipient will open that document, which installs a keylogger in his office environment. Another option would have been to select to write a mail using the vacation at the Venetian Las Vegas. And then the system creates a mail, well formatted. Dear Mr. McCarter, we hope you enjoyed your recent stay at the Venetian Las Vegas. Yeah, you stayed here. As a valued member of our loyalty program, please fill in the survey. to sweeten the pot, the first 200 respondents will receive a complimentary 2-night stay at one of our hotels. Naturally, I filled this survey because yes, I did stay at the Venetian. I'd be happy to get another night. And then you get a mail after the survey is completed. Thank you for completing the survey. You just won the prize. Please click here to claim that prize. You just need to fill in your credit card number to secure your stay. Hey, and then we get to the credit number of Kendrick McCarter. So it's not like phishing, where we just, as I said, spray and pray tens of thousands of mail in the hope that someone will click it. I want one specific person, and I build a full attack just for that specific person. There is such a tool called SnapR, which was built by a company called Fox Pro, that does something very similar to what we've shown. It is built as a Twitter, and it has more than 30% of click rate. Okay, so SnapR, a social network automated phishing with reconnaissance, and it reached 30% click rate. One of our customers asked us to do something similar within their organization, and we were able to get more than 50% click rate with their C-level executive. That's insane. Phishing mails usually get several promils of success rate at the best. Usually at this stage of the presentation, people feel that there is no future and there is no hope. Hackers are using AI, and the good guys are lagging behind. Well, check marks us. We come to the rescue, and we revolutionize the AppSec market. Every feature, every product of ours, we think how we can use AI to improve it, to scale it, to make it better. Starting with result confidence, we show the confidence level of the results based on AI. So once you mark a result as a false positive, we try to learn. We have machine learning capabilities, understanding or learning what properties of this result make it probably more false positive prone than others. And then we fine tune the order and the accuracy of the results. And in our research lab, we have many similar activities. For example, by learning how true results look like, we try to find similar results. In a similar way, how law enforcement agencies find faces in a large stadium, we learn how results look like, and we try to find similarities in your specific code. It also allows us, the next step, it allows us to recommend you how to fix your code, not only finding vulnerabilities, but suggesting how to fix your code. Just as an example, let's say that in the red is how your GitHub code looks like. We see that it is similar to a vulnerability which was found already in GitHub and was fixed as such. Then probably your code should look like the following. Also, as security experts, we have intuition. I've done hundreds of code reviews, so just by looking at the code, without even finding the first vulnerability, I have the intuition whether I'll be able to hack into that system or not. In a similar way, the way I hacked into Amazon's Alexa, I looked at it, something didn't seem right. I knew that I will be able to hack into it. It took me a couple of days. So machine learning and AI is the automation of that intuition. If you have a project that you have mostly junior developers maintaining it, it's very old code base and with outdated technology, most probably you want to scan and fix this project first versus project B. So feeding in that kind of intuition will help you to prioritize the scanning efforts if you have multiple projects. The next step is for open source software to build contributor reputation. When you hire a new developer to your organization, you most probably do some kind of a background check. That's great. But then you use an open source component and you have no idea who's contributing to that project. By having a reputation score, you know that all the contributors are validated or have some kind of a background. They did something in the past, and it's not that they have just joined the project, checked in some piece of code, which you will be using very shortly. A very recent attack happened a couple of years ago. There was a component called event stream, which was downloaded more than 2 million times a week. And at a certain moment, the main maintainer of event stream was a bit tired, and someone called Right9 Control said that he's willing to take that project and to become responsible to it. And the main maintainer said, sure, why not? I'm a bit tired. Right9 Control took control. And then he pushed Bitcoin mining and or cryptocurrency mining and stealing soft code into that package. And boom, 2 million installations per week started to mine currency and to steal currency from these servers. Gladly, it was detected very quickly, but as a concept, you don't really know who contributes code to your third-party components. So the reputation score is very handy in these environments. We talked about genetic algorithms. We're looking how we can use genetic algorithms to automatically build or supporting new languages. For us at Checkmarks, we scan your source code to find vulnerabilities to make sure that your developers are developing secure code. Instead of us having to support each language that you're using, by building good and bad code examples, we can automatically start supporting new languages without to manually build these grammars. So just as closing words, AI is all around us. We've shown how hackers are using AI to scale their attacks. But as the good guys, we use a very similar techniques to improve our finding and detecting capabilities. That's it. Thank you very much.